Let's take a look at this first question. It says, which statement is true of alkaline earth metals group 2A on the periodic table? So this question is asking about alkaline earth metals, and it informs us that it's group 2A right here. In order to answer this question, you do need to have your periodic table drawn and labeled correctly, not only with the families, but the charges and your orbitals. Answer choice number A says they are found in nature as free elements. While that may be true, there are a lot of elements that are in the other families that are found in nature as free elements. For instance, we have oxygen, nitrogen, carbon, silver, gold, hydrogen, sodium. There are a lot of other elements outside of that specific family that are found as free elements in nature, so we're going to go ahead and cross off question choice A. B says they readily lose 2 valence electrons. Let's go ahead and look at our drawing down here of the periodic table. We see that the oxidation number for alkaline earth metals is positive 2. That does mean that they lose 2 valence electrons. Because they are metals, when they bond with other elements, they are always going to want to give away their electrons so that they can become positive cations. In this case, alkaline earth metals want to give away 2. It's easier for them to give away 2 than to gain 6 electrons, so they can satisfy that octet rule. So we can keep answer choice B. It could be right. Let's go ahead and look at C. C says their electron configuration ends with S1. Let's go ahead and look at S1. So there's talking about the S orbital down here. We know that helium is also a part of this orbital. If you look at the configuration for S1, S1 is always going to be group 1A because that's where S1 ends. If you go into 2A, you're going to get S2, whether it be 2S2 or 3S2 or 4S2. If you go into S2, you're going to go into 2A. If you stop at S1, you're always going to be in 1A. So we know that answer choice C cannot be correct. And the last question says, D says that they have an oxidation state of +1. Like I said, your oxidation numbers would have needed to be labeled correctly. And this one is an easy cross out because you see that 1A has an oxidation state of +1. So we know that that is incorrect. So here, our answer is going to be C. They readily lose 2 valence electrons. Question number 2 says, electronegativity measures the ability of atoms to attract a bonding pair of electrons. Which diagram correctly identifies the period and group trends for electronegativity in the periodic table? So let's go ahead and identify a few things. In this question, we're talking about electronegativity, and they tell you that it measures the ability of atoms to attract a bonding pair of electrons, okay? They're asking which diagram correctly identifies the trends for electronegativity. So if we go ahead and look at our periodic table that you should have labeled, the same one that we used in question number 1, you should know that your snowman and your cone are for your periodic trends, okay? The snowmen are for atomic radius. We know that our cones are going to be for ionization energy and electronegativity. Okay, in this case, we are just looking at electronegativity, so we'll start there. If we look at your cones, the ones that are on the side going up and down for your groups are shaped like this, which means going this way, they're going to increase. The one that is laying down at the bottom, which goes side to side for your periods, is like this, so we know that it increases going this way. So now we need to go over and look at the charts and see which ones match what we have written down that we got from our labeled periodic table. So we see that this one says decreasing and increasing. While increasing is correct, decreasing is not, so we're going to cross that one out. This one says increasing here, which is correct, but decreasing here is not. This one says increasing and increasing, which is, we look back right here where we wrote down our notes from the periodic table, both of them are increasing. So we're going to leave that answer choice because it could possibly be correct. And then we're going to look at the last choice. It says decreasing and decreasing. Neither of those are correct. They would have to be going in the opposite direction to be labeled decreasing. So in this case, we know that the highlighted one is going to be our answer choice. Question number 3 says that the figure shows a cathode ray tube. This Says that the figure shows a cathode ray tube. This is your ray tube. Says in 1897, J.J. Thomson used a device like the one shown to discover that cathode rays were streams of photons, electrons, protons, or ions. Photons are what atoms give off. When the electrons move energy levels. That is photon emission. So we know that it's not answer choice number letter A. When we look at B, it says electrons. Let's take a look at our cathode ray tube. Up here we have a positive plate and down here we have a negative plate. We see that the stream tilts towards our positive plate, and we know that opposites attract. So we have to assume that this stream is going to have a negative charge because like charges repel. So we could say that these are electrons because we know electrons have a negative charge. So we're going to highlight B because that could possibly be a correct option. It's not going to be protons because protons have a positive charge, and we know that because this is going towards the positive plate, it has to have an opposite charge because opposites attract. And then ions are positive and negative atoms. So we have cations, which are positive, and then anions, which are negative. So the only answer choice we have here is B. Okay, question number 4 says, what is the number of atoms in 3 grams of gold? I've put your conversion chart below. This will not be given to you on the ACP. It is something that you need to memorize, but it is a helpful tool when doing your conversions, okay? So we're going to go through and highlight the important information. They're asking for the number of atoms in 3 grams of gold, okay? So we are starting over here with mass and grams because that is the number that they give us. And we are going to end with particles. Because we go from mass to particles and not mass to moles, we know that this is going to be a 2-step equation. Your 2-step equations are always going to be set up like this. We're going to go ahead and take out the information they give us. So they give us 3 grams, and that is what you write in your first blank, 3 grams. Remember, your units have to match diagonally, so you're going to put grams down here as well. So we've done our mass. And we're finished setting up the problem. So we have moles that goes in the middle right here. Remember, you always have 1 mole on top and 1 mole on the bottom. Because we're ending with particles, you have to go and find Avogadro's number, which is going to be right here on your formula sheet that you will have for your ACP. That number is going to be 6.02 times 10 to the 23rd. Remember that particles, atoms, and molecules are all the same thing. You can use them interchangeably in your problem. So we're going to go ahead and take that number, Avogadro's number, and put 6.02 times 10 to the 23rd right here. Okay? The last thing that we need to find and pull out to solve this problem is molar mass. And remember, your molar mass comes from your periodic table. So we're going to go ahead and find gold on the periodic table, which is right here. Gold's mass is 196.967. So remember that rounds up to 197 because you have a 9 here that's going to round this 6 up to 7. Okay, that is the number that we take and we write right here. So 197. If you plug all of this into your calculator, 3 times 1 over 97 times 6.02 times 10 to the 23rd over 1 mole, you would get 9.17 times 10 to the 21. Okay, question number 5 says that the table shows 2 isotopes of an unknown element. We have isotope X and then isotope Y. Isotope X we're going to go ahead and label as our first isotope, and then isotope Y is going to be labeled as our second isotope. And you see here you have your mass, and then over here you have your percent. abundance, and we're solving for average mass. Okay, the question then proceeds to ask, what is the average atomic mass of the unknown element? So we have two isotopes of an unknown element, and then they are asking what is the average atomic mass. We also know that average atomic mass is labeled as AMU. This specific question is not asking us to find the unknown element, it just wants the mass, okay? So at the beginning of the semester, we learned average atomic mass and what that is and how to calculate it, and this is the formula that you were supposed to use. In this specific problem, we only have two isotopes. We have isotope 1 and isotope 2. Isotope 1 is going to be isotope X, and 2 is going to be Y. If you were to have a third or a fourth isotope, you would simply repeat this part of the equation and change it to mass for isotope 3 times the percent mass of isotope 4 times that percent. The biggest thing is to make sure that you divide by 100 once you get your number that goes at the top of your fraction, and that will give you your average atomic mass, what we are looking for in this problem today. So you're going to multiply each isotope by its percent abundance and then calculate the sum of all products and then divide the sums by 100. So let's go ahead and do that. So mass of isotope 1 is going to be 10.013 times our percent, which is 19.8, plus our mass of isotope 2, or isotope Y, which is going to be 11.009 times our percent, which is 80.2. And like I said, remember, make sure that you divide everything by 100 when you plug it into your calculator. Once you plug that all into your calculator, you would get 10.8 AMU. That is going to be your answer for this specific question.